Let us describe the mission for a power n, b power n, c power n. So first we will have to scan A's. So delta of q0 comma a. Let me go to q1 and change this to capital A, and direction is right. So this says state. This one says either you retain A or the replacement symbol. And this one is direction. Okay, so if the input is like AA, BB, CC, first we will replace this by A and we will be at Q1 now. Then with Q1, we will have to scan all of this. So Q1 comma, we do not change this A, so A remains A, direction is R. Now at some point in time, we will reach this, so which means delta of Q1 comma B is Q2 comma capital B. Now we change this to capital B and move right. Fine. Now you may have to scan all these B's before we hit this. So Q2 comma B is Q2 comma B comma R. Now after scanning this, sometime later we will hit C. So delta of Q2 comma C is Q3 comma X. Now we want to change our direction. So we say Q3 comma X comma L. Fine. So first time we replace this by A, and then using this we scan all of this. Then the moment we hit little b, we flip this to capital B using this. Then we scan all of this using this transition. Then the moment we hit C, we flip it to capital X. Now we will have to go back until we see this, then we continue this process. So while going back, now you are in Q3. While going back, you will have to scan all these little b's. So Q3 comma B is Q3 comma B comma L. Then you may have to scan this capital B also. Q3 comma capital B is Q3 comma capital B comma L. Then you may scan little a. Q3 comma A is Q3 comma A comma L. So at some point in time you will see this. When you are in Q3, you hit capital A. Now you need to change your direction and start this procedure. So which means if you want to start this procedure, you should go to Q0 and this A remains A, and let me change the direction to R. So what is that we have done? With the help of Q3, we start moving left until we hit the leftmost capital A. The moment we hit leftmost capital A, we change our direction to right and then continue this process. Fine. Now, when we continue this process, again we will reach Q1. This becomes this. Then we scan all of this using Q1. Then we will have to scan capital B before we hit small b. Fine. So we only have transition for little b, but for capital B we do not have. So let me add that. Delta of Q1 comma capital B is Q1 comma capital B comma R. First time you will not see, you will immediately see little b. But subsequent iterations, you may have to scan capital B's before you see little b. So write that. Then after that, you see little b, then use this to flip it. Then scan little b's, then you hit C. But subsequent iteration, you may have to scan X before you look at C, which means delta of Q2 comma, after scanning little b's, you may have to scan capital X, Q2 comma X comma R before you hit this. Correct? Then Q2 comma C is Q3 comma X comma L. You change your direction, and now when you come back, you will have to scan capital X before you see little b. So delta of Q3 comma X is Q3 comma X comma L. Then Q3 comma B is Q3 comma B comma L. Then you scan capital B, scan little a, then you get the leftmost a. Fine. So what am I saying? Something like this may be there. A, B, B, then X, C. The third iteration, you flip this to A, then flip this to B, and flip this to X. Now when you go back, you will have to scan all of this. That's what this one is doing. And before you start scanning little b. And if you don't find little b, then you start scanning capital B. Then you find little a. If you don't find little a, then you start scanning capital A. Fine. Let's assume it's a valid input, something like triple A, triple B, and triple X. Then we come back and we hit the leftmost A, we change our direction, and we read this symbol. Now, if we change our direction, we will be at Q0. So delta of Q0, we ideally expect little a so that you can continue the operation, but you are done with your replacing a by capital A, B by this, and so on. Now instead of seeing little a, we are seeing capital B. What does that mean? Which means we have exhausted capital little a's. Okay, now what I do, we need to scan this to check whether it is a valid input or not. Now we go to a state called Q4, Q4 comma B comma right. Now while we are at Q4, we simply scan all of them. So Q4 comma B comma R. Correct? Now at some point in later, we may see X, then we go to Q5 comma X comma R, then delta of Q5 comma X is Q5 comma X comma R. Supposing it is a valid input, now after some time, we will see delta of Q5 comma dollar. We can say go to a final state and dollar remains dollar and stop the machine. Fine. It's a valid input, which means after exhausting A, now I am seeing capital B. Let me scan all of this. Let me scan all of this to see whether I see a dollar. Why should I scan all of this? So it may so happen that if it is a invalid input, For example, we may get something like this: A, B, little b followed by XXX, or maybe triple A, triple B, and then followed by something like this. So I need to scan all of this and check whether I hit a dollar, and while scanning I should not encounter a B or I should not encounter a C. Fine. And in fact I should not see little a again, all that. Okay, so let's fill those part. With that, this description is complete. Fine. So now with the help of Q4, we are scanning these capital B's. Okay. Supposing while scanning that I come across a little a, then it must be reject and stop the mission. Halt, H means alt. Or while scanning you come across B, which means more B's, then also you reject the mission. Fine. And so what is this telling us? After this B, you may find one A. Fine. So if such things are there, then it has to be rejected. Fine. So on the similar line, now you scan X using Q5, you see that there is no issue with respect to A and B, but while scanning this you come across C. So delta of Q5 comma C you must reject and stop the mission. So while scanning you may find input like this, say A, B, C, maybe AB. Okay, so while trying to scan that, you encounter A, then also one has to reject. So while scanning we encounter a B, then one has to reject. Fine. Similarly, at the start you read B, then you reject QR comma B comma halt. Similarly, at the start you encounter a C, then it must be a reject. Then one more. Maybe after reading this A, instead of reading this, you come across C, which means after scanning these A's, you will be at Q1 and you look for a B, instead you see little c, which means delta of Q1 comma C must be a reject. So the idea is the following. First we write the valid transitions and then we look for gaps, and after reading a B you come across little a, or after reading C you come across A or B, and all that one has to reject. Similarly, beginning with B or C, or after seeing A instead of B you see little c, all that should be carefully taken into account as part of the description. Fine. So let me go through this design again. So the logic is to flip the first A to capital A and scan the remaining A's, then flip the first B to capital B, scan the remaining B's. So this says you flip to capital B. This one is, I'm sorry, this has to be little b. Q2 comma B comma R. Then we come across C. We change that to X. And then we change our direction. And we need to scan little b's, then capital B's, then little a's before we hit a capital A. At that point, we change our direction and continue our process. So, which means we should go back to Q0. Fine. But this is okay for the first iteration. For the subsequent iteration, when we say we move right, we may have to scan capital B's before we see little b. We may have to scan capital X before we see little c. Same is the case when we come back. When we come back, we will have to scan capital X and similarly little b's, capital B's, little a's before we hit this capital A. Which is why the remaining transitions are given. So subsequent transitions, we may not see little b immediately. We may have to scan capital B before we hit little b, which is why this is given. Similarly, we may have to scan capital X before we see little c. And when we come back, we will have to scan X, and which is why this is given. And when we come back, we scan X, and then we scan little b, capital B, little a, then we hit the leftmost A. Supposing it is a valid input, which means we are done with replacing A by capital A, B by capital B, and C by X. When we come back, you get to see that at Q0, instead of seeing little a, we see capital B. Now I need to check whether this is a valid input or not, which means I need to scan until I hit $. While scanning, I should not see any other symbol. I should not come across little a or little b or little c at any point in time. And you scan checking whether it is all b, it is all x, and finally you hit $, then you stop the mission. But you may come across, after seeing capital B, you may come across little a, then reject. Or you may find excess b's, reject. Similarly, for the third component, you may find excess c's, or you may come across a or b. In all cases, input must be rejected. Or we may start with B or C, that must be rejected. After seeing A, instead of seeing B, we come across C, that must be rejected. Fine. So this is how we usually write. We come up with a logic, and then we describe a mission capturing valid inputs, then start filling the gaps, which will take care of invalid inputs. Most importantly, every valid input must be accepted and every invalid input must be rejected. So your description must be in such a way that it ensures every input in sigma star is taken into account. Every input in sigma star, either it takes, the mission should take the input to accept state or the reject state. Fine. Such a nice computing model. Let's explore more case studies.